All right, so in this lesson, we're going to use what we learned about fractions and refer to them through roots. So traditionally, and I'm sure we'll go over it, but traditionally, a root, a square root is like this, which is also written through a fraction like this. There's basically an invisible 2 there. So if we're doing a cube root, 27, and I'm not sure if I've done this in this video series, but the way you find cube roots is you go like, well, what makes 27? 3 times 9. And then you make 9 is 3 and 3. And oh, look, I have a group of 3. So the cubic root of 27 is 9. And you need to make sure if you're breaking it down, you have to cancel it out. If there's anything that doesn't fall under that group of 3, it gets left inside the square root. Um, so a cubic is just written as 1/3. Let's say I had a squared here inside the cubic, then it would be 2/3. Basically, your numerator is whatever power goes here, and your denominator is whatever power goes here. So that's the main relationship between the rational exponents that are rational. And let's get into the actual lesson, which will describe that in a little more detail. So radical root, so that's this right here. And n just means a power that we have not determined yet. It's a variable. So when we're writing like this, a root, that n, oh, and then here's going over everything that we've talked about. This is your result would be the radicand. It's a term that doesn't come up too much, but it's a quick way to resolve to it. It's like, the nth root of x is p, or the radicand of nth root of x is p. All right, and then we can write it in exponent form. So p to the nth root is x. So that's it's a quick way of relating roots with exponents. So you can write it this way, the nth root of x is p, or you can write it this way where it's like p to the nth root is, or p to the nth power is x. So that's the relationship between those two. And as I mentioned before, you can just write it with the denominator. Whatever the root is here, that's the denominator. So if you're writing something like the fourth root of 16, you can rewrite this in a way. Rewriting it very interesting in the sense that I think it's almost kind of moot if you want to solve it that way, because if you already know 2 times 2 times 2 times 2 is 16, then you already know that the fourth root of 16 is 2, because you already multiplied it that many times. But it's a strategy nonetheless. I think they're just trying to show you guys the relationship between them. So let's say we have something like this, a fraction. How are we going to deal with those? And they give you an open resource if you need them. If you not need them, but if you want to look through it, it's kind of interesting being able to just have these types of worksheets. So here's a worksheet for you. I recommend printing it out. They're very useful, and it does help you kind of understand these relationships a bit more. Oh, this is actually the worksheet that is right here. The worksheet that I mentioned in the first video after the guided notes. All right, so let's take a look here. All right, so if we're looking at this, we notice that the denominator, the number at the bottom, is 5. So we're going to look which one of these has a root of 5, and that's the only one is this one, so this has to be the answer. Notice that the 3 is still up there in the power because it's the numerator, and now we're looking for one with the root of 8 because 8 is our denominator. So we look here, boom, right there. Next one we're looking for has a cubic root. So that has to be this one. And notice how the 5 is still as a power because it's in the numerator. The next one is a half, so it's just a square root. I don't know why they put the little 2 there. I think it's so you guys can get used to it. But normally if you have a denominator of 2, that root should be invisible. And that's mainly because 1, you can't do the root of 1, it's itself. It's kind of like how you never have 1 in front of a number. All right, so simplifying these. So the way to simplify it, again, oh, they actually explained it a little bit better here. What they're doing here is they're kind of like doing a factor tree. I think kind of just saying perfect roots are pretty much pointless because if you knew it was a perfect root, you wouldn't have to break it down. This is more of the style that I'm used to, where it's like, hey, let's break this down into something else. It's still a little moot because um, you would have to know what the perfect root is. So in this case, they're like, oh, a cubic root. Well, 8 is a perfect cubic root that divides into there. So they're essentially saying like, hey, you need to know your perfect squares, your perfect cubes, your perfect whatever. And I mean, it could work, but I prefer the factor tree method. So if I were to break this down, let's pretend I had no knowledge of this, and I'm like, 160. Oops, let me do this in a better color. 160. Well, I know 4 goes into 16, so let me try dividing by 4. And I'm like, okay, I got 4 and 40. Okay. And then I'm like, well, 4 is 2 and 2, and 40 is a 2 and 20. So, oh, cool, I have these group of 2s. Awesome. And then I cross out the 4 because I broke it up, cross out the 40. I can even cross out the 160. I'm going to break up this here. So I'm here and I'm like, okay, breaks up into 4, breaks up into 5. This breaks up into 2 and 2. And I broke everything up as much as I could. Sorry for the slanted tree. And I do have a pair of 2s, but I'm looking for a cubic root. So the only thing I really have is a 2. And I'm going to multiply everything that's left on the inside. These are all factors, so they all multiply together, which, to no surprise, is the 20, because we got nothing out of 20. This 5's kind of in the way. So that's how I prefer doing it, as opposed to like, hey, you have to know all of your perfect roots. All right, moving on. So let's say we have something like this, and we need to simplify it. Well, they're saying like, hey, why don't you just break up that 8? So if we broke up 8, 8 is 2 and 4, 2 and 2. So in other words, 8 cubed is 8. We're crossing out this 4 because we already broke out the 4. So 8 cubed is equal to 8. 5, you can't really break down into anything besides 5 and 1. So, and we never include 1 when we're doing a factor tree. It's kind of pointless. So basically, you can't factor out a 5. And just a reminder, the word factor means multiplies, into. So a factor of 2. So for example, a factor of, let's say, 15, or factors of 15 are 2 or 3 and 5, and technically 1 and 15. We usually don't count the 1, but sometimes we will need to know that 15 is a factor, so we do have to include 1 technically. breaking it down by 1 doesn't really change anything, so that's why we never really include 1. And then from here, we can distribute that. We get these mixed numbers. So we can just leave it in mixed number form, at least for these exercises. But you can always reduce this in a way, which I'm sure we'll do in the next slide. So hold on. So let's say we have this. Well, we can break this out into this 3 halves. Breaks out into 2, 2 over 2, because 2 divides into 2 nicely, plus 1 half. Well, this 2 over 2 becomes a 1. So that means that it's going to go outside this square root, as we'll see right now. So it's going to go on the outside. Since these have the same power, and it's a fraction, they end up going on the inside, and then we can just simplify by multiplying, and it becomes a 10. So if you guys need more time, you guys can always read this, but essentially what they're doing is they're just breaking it up nice and slow. All right, let's solve some problems with this new knowledge. All right, so if we're looking here, first things first, I'm going to want to do this to the 1/3. So I'm going to want everything gets that little 1/3. So you can see that here. Everything's being multiplied. The 2 is 2/3 because they already had a 2. So I'm going to say that's my second step. Oh, actually, no, hold on. They want us to do this one first. Everything to the 1/3. And then they want us to distribute that 1/3 to everything after we do that. I was actually hoping to find this one first, but I saw this one first. And then from there, what we're going to do is we're going to break everything up. So we find that 150 to the 1/3 power is the same thing as, let's see here. Where is it? Huh. I'm trying to see where, oh, I see. They're breaking these up into the smaller ones. So this is the same thing as this right here. The main difference we see here is we broke up the 120, and they're also breaking up this 7 over 3 to make it 6 plus 1/3. From there, we can separate them. And from here, we can divide things out. So we'll be able to divide out that y, so it becomes y squared. And this one will stay inside with here. And then from here, we're going to take that numerator or denominator and make it the new root. All right. And then let's take a look at this other one that they're going to want us to do here. All right. So this one, I hate it when they make you guys do the multiple choice. That one was at least nice because they broke down the steps. So here, the first thing we're going to do is we're going to do 2 over 5, and then x to the 4 over 5, and then y 12 over 5. Well, what we're going to do now is I always kind of pull out this 32 and kind of start breaking it out. So if I break this out, I get 5 and, or 4 and 8, and this is 2 and 4, which is 2 and 2. This breaks out into 2 and 4. By the way, I'm crossing out anything I break up. And this is 2 and 2. So if I look at this, I'm like, well, I'm going to have these right here. That's a group of 5. So this becomes, and this is getting rid of that 1/5. So then I have this 2 to the 5th root of 2. And I need to square this. All right. And then over here, well, I can't really do much with that 4 to the 5th. With the y, however, I need to find multiples of 5. Well, multiples of 5 are 5, 10, 15. Well, 15 is too high for this 12. So that means I have this 10 over 5 plus 2 over 5. So now I break this down even more. I'm going to want to do this squared right here. I need to square this out a little bit. So if I'm going to square that out, let me go back to blue. I'm going to get 4, 5, fifth root of 4. And you can't, if you break out 4, you don't really get a fifth root, so it's just going to stay in there. Then we still have x. Oops, sorry, hold on. I want to split off. Oh, wait, no, I can do it this way. Do this here. And then I can change this to y squared and y to the 2/5. So now I want to get all the fifths together and all of the non-fifths together. So that's 4y squared. I have a fifth root. I have a 4 in there. I have an x to the 4 in here because the numerator. And I also have a y squared in here because of the numerator 2 right here. All right, so the only one that matches up with that is this one. Oh, wait, nope, backwards. This one. I got the 2 and the 4 mixed up. So it has to be the second one. Cool. Let me erase all of this. Moving on to the next one, and then you can see how they did it. Pretty similar to how I did it. They just don't show how they broke up the 2. And I must have miscounted somehow because they don't have the 4. So I am missing a 4, so definitely go back to this and refer to this because I'm missing a 4 somehow, or I got an extra 4 than I shouldn't have had. Squared it. Weird. All right, moving on. Oops, wasn't supposed to do that. All right, so now we have this. So these are a lot more challenging to do. Some of you guys might have seen the answers right now, but we're looking to break up the 7, 2. So what I recommend for these, there's a couple of rules that follow. Rules for multiplicity. So one of the obvious ones that a lot of you guys know is if it divides by 2, it ends in a 2, 4, 6, or 8. One that you guys might not know is if it divides by 3, divides by 3, if you add up all the digits, so this is 15 or 16, this is 18. If we do 1 plus 1, that's 9. 9 can be divided by 3. So that means this can be divided by 3. So this divides into 3 nicely. Another rule is, everyone knows this one, is if it divides by 5, it ends in either a 5 or a 0. So this one does not divide by 5. We know it divides by 2. Another rule is divide by 6. So divide by 6, it has to divide by 3 and divide by 2. If it divides by both, then it divides by 6, which makes sense because what is 6 but 2 times 3? So if something divides by 2 and 3, then yeah, of course it's going to divide by 6. Another one is 7 is really difficult. So I haven't memorized that one. But the other simple one is divides by 9. And that's the same rule as the 3, except if you add them all up, they should eventually add up to 9. which we already did with this one. So this one will divide by 9. So let's just do the divide by 9. Usually I try to do 9 first because it's so big. If it doesn't follow any of the rules, I usually start doing divide by 7. You're not really going to be doing anything that doesn't divide into anything smaller than 9 or bigger than 9, I'm sorry. So that's where you're going to want to leave off on this. So this divides into 9 because that's 9 goes into 9 one time. 9 does not go into 7, so we're going to put a 0 there. But 9 does go into 72. It goes in there 8 times. All right, and if I see here, 1 plus 8 is 9, so I can probably divide this by 9 again. So I'm dividing this by 9, get a 1, carry the 1, that's a 12, and here I'm going to get a 3 and a 4. Now I'm doing the fifth root, which works out because 9 is 3 and 3 and 3 and 3. So I broke up these 9, so let me cross them out. I broke up the 108, so I'm going to cross that out. So I have 1, 2, 3, 4, 5 threes. So that means I have a 5 and a fifth root of 4. Yes, I can break up the 4 into 2 and 2, but that's not going to help me anymore. So I'm going to look at this. I'm going to go like, okay, so cool. So I need oops, why did I say 5? I meant to say 3. I have 3 5s. So it's 3 to the fifth root 4. So I need this one right here. So that's the work on how to figure this out. All right, next one. All right, the third root. All right, so I'm looking at this. I see that I have a 4, and an 8. Well, I'm going to try 4. I'm going to break this up into 4 because I know 4 goes into 4, 4 goes into 4, 4 goes into 8. So this is going to be 2, 2. I'm sorry, 2, 2. Blah. 4 goes into 4 one time. 4 goes into 4 one time. 4 goes into 8 two times. Well, I know this ends in an even number. I could try doing 4, see if that works. It actually does because I know 4 goes into 100 and 4 goes into 12, but I'm going to pretend that I don't know. So I'm going to do a 2, and I know 2 goes into 10 5 times, 6, and 56. I know that's 7 and 8. This is just from experience. I don't know why I somehow randomly remember that 56 is 7 and 8, which is 4 and 2. And then I'm like, okay, this is 2 and 2, and this one is 2 and 2. And just to make things easier, I'm going to cross out all the ones I've already broken up so they're not in my way. All right, cool. So now I'm going to circle the ones I need. So I'm looking here and I'm like, okay, cool. I'm only looking for 3s. So here's a group of 3 2s. Oh, wait, I have another group of 3 2s. Oh, I forgot to cross out the 8. So what happens here is I have 2 times 2 on the outside, and I have the cubic root of 7 on the inside. So that means that I need to do a 4 and a 9. Perfect. Got that right there. I'm going to clear that out. And now I need to do the square root of this number. Oof. Well, that seems hard, right? Well, I'm looking at this, and I'm actually going to show you guys a neat trick. Um, Normally doing sevens is hard, but guess what? 7 goes into 35, and 7 also goes into 28. That I just know because 7 times 5 is 35, and 4 times 7 is 28. So I can take out a 7 here. It's 5. 7 goes into 35 5 times. 7 does not go into 2, but 7 does go into 4. From here, it's like, wait a minute. 4 plus 5 is 9, so I know this has to divide into 9. Technically, 5 plus 0 plus 4 is 9, but same thing. So I know, I'm like, okay, well, 9 goes into 50 about 5 times, and 9 goes into 54 because we have a leftover 5. 9 going into 50. We did the thing, and we had uh, 5 left over, so we have that 55 there. So that goes in there 6 times, and as I mentioned before, I know that this is 8 and 7, and I'm looking for a squared. So I'm looking for any couple. Here's a couple. Here's a couple. Well, let me do that in a different color. It's a terrible color. And we're going to cross this out, and then we have a 2 and a 4, and this turns into 2 and 2. And here's a couple. So on the outside, I'm going to get 2 times the red 2 times the yellow 7, which, as I mentioned, I know is a terrible color. And on the inside, I'm going to get the square root of 2. So on the outside, I have 4 times 7 square root 2, which turns into 28 square root 2. Now I feel like I'm missing something here. 956. Oh shoot, that was supposed to be these are supposed to be 3s. Whoops, not 2 and 2. So this is a 3. So 6 times 7 square root 2. 6 times 7 is 42 square root 2. That makes more sense. I was like, wait a minute, that's not working. 9 doesn't divide into 2 and 2. It's 3 and 3. So that was a big whoopsie on my part. Also, an easy way to have told is this is a square root. This is the only one with square root. But now you know how to make this easier, or how to do this. Not easier. The easiest way would have been like, that's the only one with a square root. Just like we, even though we have 3 options, we need to find one with a 4th root. Well, guess what? We either have this option or this option, so we can't even do that easier. But if we do this one, we have 40 and 50. Well, I'm going to do to the power of 10 because it ends in a 0. Oh, look, 4 plus 0 plus 5, that's 9. So I'm going to break it up into 9 because it divides. Again, if you add up all the digits and they're divisible by 9, you can try dividing it by 9. Well, 9 goes into 40 4 times. We have 4 left over, and 9 goes into 45. That 5 times. Oh, guess what? 9 goes into 45. All right, and we're doing the 4th root, so this is 3 and 3, 3 and 3, cross that out, cross that out. Again, we can break up the 10, but it doesn't benefit us. We have 4 3's, so 3 goes here, and the 4th root of 10 times 5 goes inside, so we get 3 to the 4th root of 50. And that's how we get that right there. Very cool. Sorry if I did that fast. It's just time's limited for this video and I wanted to get through it. So that's how you basically break these down, is with a little factor tree. Hopefully my writing is legible enough for you guys to understand it. Let me submit this. All right, cool. And then there's that. So the self-evaluation, if you guys had a hard time with factor trees or understanding these, write that down. Write down anything you're having trouble with. Go back and really think about it. Don't just skip it. This is a good time for you to look at the work that they did and be like, I don't understand how they get these numbers. How are they getting this 5? How are they doing that? and really write it down. And it might be something you might want to bring up to your teacher, or heck, leave in the comments below if you're watching this on YouTube, um, and you're not in my class. And then I can try to help out with that. All right, let's see what we have here. So summary. These power rules, definitely understand these power rules. We've learned them before, but now we know that we can apply them to fractions too. And we also know that roots are a exponent in disguise. All right, so be sure to study those up for the test, and we'll see you again in Module 3.